Hi guys. Algorithms. Okay, your first pseudocode. Hope that went a little bit okay. They were rather easy, straightforward ones, and very much similar to what we have seen already so far. So describe an algorithm number 6 that takes as input a list of n integers. And finds the number of negative integers. So we first have to go. So the list has n integers. And we need to find how many of those are negative. Okay, let's say there could be scores, and we want to see which has negative scores. How many negative scores are there? How many positive scores are there? Okay, so let's enumerate this again. We want to start from 0. I'm going to start from 0. I don't think I need to start here from 1. So but then n integers. Okay, so I'm going to start from 1. I'm going to be lazy. That I don't have to renumber. Okay, and this is my list of n integers. So what will I do? Well, I'm going to go through the list, and each time I find a negative, I'm going to say, oh, one more negative, oh, one more, oh, and then the positive, okay, forget about it. So in other words, I'm going to have a variable that counts how many, I'm going to keep track of how many negatives that I have as I go through the list. So it's going to be a simple loop through the list. So I'm going to loop through list, and each time record if negative by increasing the negative count. Okay, so each time I find one, I'm increasing the count of negatives. Okay, that's the description somehow, very briefly. So let's do the procedure, the pseudocode. So okay, procedure. I'm going to have to give it a name. I'm going to call it procedure. How many next? Okay, and how many next is a program that has an input a list of integers a1 up to an. Why is this thicker than I want it to be? Okay, I'm going to make it a bit thinner. Okay, how many next? That's going to be my program. And as I said, I'm going to keep track of how many negatives there are, and I'm going to call that counter. Just call it neg. Okay. Very typical is that neg is not yet defined, but I will need it, so I'm gonna initialize it. So neg. The first thing I'm gonna say, okay, let's assume that we are in a good situation. There are no negatives here. Okay, neg is 0. And then what I have to do is what I said. I'm gonna loop through the list. That is a for loop, right? For my counter going from 1 to n. So from I going from 1 to n as I go through the list. And what I have to do? Well, there's a comparison, and the if here already tells me it's going to be an if then, right? So if the number that I find is negative, then I have to increase neg. If not, I don't do anything. So it's the negative. So when you do an if then, you have two options. You have an if then, or you have an if then else. If you only have to do one thing, there are two possibilities. If it's true or false, right? If there's only one occasion in which you have to do something, then that is going to be, you want to use an if then, right? So I only need to do something if I have a negative number. So I'm going to test for negativity. I could have tested for positivity, but testing for negativity is what I want here. So let's see. And if, first of all, I'm doing this inside the loop, so I have to indent. So if then. So what it is that I'm going to say, I said I'm going to compare my element. Which element? I? No, not I. The ith element in my list, and I is just keeping track of which element I'm talking about. So AI, if AI is negative, that's what that means, less than 0, then I'm increasing my neg. Then neg is redefined to be neg plus 1. That is, I'm adding 1, I'm increasing the counter. And really, that's it. I'm done, right? Nothing else needs to be done. Of course, I have to tell my program now, okay, when you did all this, when you go through the whole thing, stop, and that's the return. Don't forget the return, otherwise you have what they call a hanging program. And what I return? Well, return neg, right? because I need to know how many negatives there are. And that's going to be exactly the number of negatives. Okay, that's not so hard, right? Number 8, here you have to design an algorithm that has a list of n distinct integers. So L is a1, a2, an, they are distinct. Notice in the previous one they didn't need to be distinct. Sometimes one needs this information for purposes. I don't exactly know why it's here. No, because one has to find the largest one. Yeah. You want to make sure there's only one largest. If you're looking for a maximum, there could be, if the list is not distinct, there could be several, the maximum could occur several times, but we're assuming they're all distinct, so it can only occur once. And it will occur once, of course, there's always a maximum. Okay, okay, so L is the list, and now what we have to do, find the location, so it's more than just answering yes or no, find the location of the largest even integer in the list. If such a thing exists, if the list is all odd numbers, then you return 0. Okay, so that's typical for location to be 0, if meaning nothing, because we start numbering from 1 here. Okay, so I'm not going to even write down in words. I said it in my head what I'm going to do. Well, let's say it. Sorry, I didn't say it yet, but let me say it just like in words. And you can always look at the transcript if you want to see a written statement. What I'm going to do? Well, again, I'm just going to go through my list and each time record the largest even integer that I have. Now, I have to think a little bit about initialization. It's a little bit tricky here because when it talks about integers, I don't want to do this, and I want to say here positive integers. There's a little bit trickiness, and I'll come back at the end if you want to do this really as it's stated, but let's do positive integers. So I'm gonna keep track of what I think is the maximum. And so each time I go loop through the list, and each time I compare the element in the list that I'm currently working with the maximum that I currently have. And if they're equal, if the new element is bigger and even, then I make that the increase the location. I call that the new location. Okay, so what I'm going to do is I'm going to say, but remember we have to also give the location. So I have to give the location, but at the same time I have to keep track of what the value of this largest thing is. I can do with just one, but it's sometimes better to have some extra variables that keep track of everything so that you don't each time have to recalculate everything, right? Of course, if you know the location, you know actually the value because you just look at, if the location is 7, then you look at A7. But it is sometimes easier to have these numbers already in your mind separately. So here's my proposal, because you might have done a completely different thing. So procedure, and so this is largest even, let's call it largest even, okay, largest even, that's how I call my computer program, largest even. It's not large Steven, it's largest even, okay. So again, A1, AN, and these are distinct positive integers. I'll say what needs to be done if there might be negative. And this comes here already. So remember, I want to keep track of two things. I want to keep track of the maximum. And so at the moment, I'm just going to say maximum is 0. And as I progress, maximum will be always a bigger, even number. Okay? I don't need to do this, but I like to do this way. But I also need to keep track of the location. And in beginning, I'm thinking, well, the location could not work at all. So let's say 0. Right? Because remember, that's the output if there is none. So I better already have an output that I want, insert one of the equations that I encounter, right? So if nothing happens in the rest of the program, my answer will be still correct. The maximum will not be correct, by the way, but the location will be correct. Okay, so what we need to do, well, we have to go through the list. So that's again a for loop. Is it a while loop? Think about it. I don't think so, right? I think this, you could always concoct it as a while loop, but it's much easier to do a for loop. For I going to, let's see, what is it? For I going from 1 to n, we're going to the list. And we're going to do a comparison again, an if then, right? So if, let's see. When do I have to do something? If the element is even and it is bigger. Okay, so if then. That's the only case I have to do something, and again, therefore, I use an if then and not an if then else. So I'm going to say if the current element, and that, remember, that is the I keeps track on which element I'm dealing with. That the counter I. So if AI is even, and sorry, it should have been all inside here, but I'm not going to do that. So if AI is even and AI is bigger than the max, okay, then I have to redefine what the max is. The max is now AI, but also the location. The location is now this I, right? Both have to be redefined now. I know I have a new max and I have a new location. So if AI is even and the AI is bigger than max, then I do this. Okay, so since this is something that you have done a couple of times only, so let me be a little bit more precise. This, if AI is even and AI is bigger than max, then do whatever I did there, the indented, no, the 2 steps here. So there's one more indentation because these things have to be done. If you can say, what about this? Don't I have to spell this out? No, remember pseudocode, we can say sentences here which we assume that everybody kind of knows what that means, or at least it must be that there is a program for that. AI is even. Okay, you divide by 2, if the remainder is 0, then it's even, and if it's not, then it's not even. That's how you do this, so there's no need to spell out how you do this, right? So that's, and therefore my program, and let's see, this will work, right? If it's no even number, then location will be 0. As I said, the max will say it's 0, but that's actually not correct, right? Because there is no max. But in the other circumstances, if I find a largest even number, that will be exactly the max here, and that will no longer change. This only will change if there is a bigger one. So, and the bigger one is even. If there is a bigger one but it's odd, then it will not change. And so everything works perfectly. So again, we have to do return. So return, and with the question asked the location, so I'm only going to return location. But if you're curious, I can tell you, or can tell you what the max is too, so you could output that too. Okay. So why is this slightly different in the case there were the integers? So okay, I'm gonna do this in red. So suppose we had really integers. The problem is that I'm not sure that the maximum is 0, right? It could be that my integers could be that this is the list, -8, -7, and -3. What is now the maximum of this list? That would be this guy, which is a negative number. So if I say max 0, I will never find that number in my check here, right? So I have to take a number that is smaller than everything in the list, and I don't know because I'm kind of trying to find the maximum. So now you ask me the minimum of the list. I cannot assume that I know the minimum if I'm calculating the maximum. It's kind of the same type of problem, right? So how do you go past a problem like that? What you do with a problem like that? Well, see, so in other words, we don't initialize, and so what we do, if AI is even, then okay, so how to repair this? It gets a little bit trickier. Yeah, see, I have to record if AI is even. Okay. What I could do is okay. It's, as I said, that's why I don't like the fact that they put it in there, because I'm not saying this is the only solution, but what I would, for instance, do is say I call max star. Okay, so if AI is even and AI is equal to star, what does that mean? That means I have not found a maximum yet. So then I would do maximum, what I need to do. But else, what I have to do, if AI is star, if AI is given, then, yeah, see, I'm sorry, I don't want to do this because it gets really tricky. I just have to make sure that. Another way, the problem is that we hear already an AND statement here. It gets really tricky to do this. Another way of doing that is putting the max. The very first time that you do find an even number, you would call that the maximum. So you would first have to search for an even number. And if you find one, then you say, okay, that's going to be the max. You stop and you start over again, so to speak, or you start from that number onwards. It's very unnatural to do that, and I think it's a typo that they should have put their positive there. Otherwise, it gets really tricky. I just want to repeat that if I scratch out positive, then the original thing will not work, because in the original one I was, remember the list that I gave you, right? If the list consists all of negative numbers, then this comparison will never give me anything, because if I compare in here, so again, we have to go back here to the original statement here, right? That's not going to work. That was the original statement. But if max is 0 and all the numbers are in negative, then this will never happen, and so you will not get the right answer. Okay, so what you have to do is, let me put it in words without working it out, because I said it's much uglier to do it then. I have to first look for an even number, the first even number that I encounter. Okay, if that doesn't exist, okay, then we know there is no maximum, so that's okay. When I encounter the first negative number, even number, I call that the maximum. And then I start doing this from then onward. So I don't start from 1, I start from the position where my first even integer was found. But that really makes the program almost twice as long, just for this stupid little thing that I have to think about. So let me just stop here. When I would ask you something, I would make sure that it is compact and nicely, can be compact and nicely done. Okay, so these are just some easy examples. We have, of course, much more complicated examples that we have discussed in the lecture.